the question is FIR filter is given by, they have given the difference equation and we need to draw the lattice structure. I should take the difference equation and we need to find out the system function first. So the difference equation is y of n, which is equal to x of n plus 2 by 5 x of n minus 1 plus 3 by 4 x of n minus 2 plus 1 by 3 x of n minus 3. Okay. Now to this I should apply Z transform. So if we apply Z transform, so y of z will be equal to x of z plus 2 by 5 z power minus 1 x of z plus 3 by 4 z power minus 2 x of z plus 1 by 3 z power minus 3 x of z. Now what let us do is, let us take x of z as a common factor in the right hand side. So if I take x of z as a common factor, the expression will be 1 plus 2 by 5 z power minus 1 plus 3 by 5 z power minus 2 plus 1 by 3 z power minus 3 into x of z. Now let us move x of z towards left hand side. Therefore, y of z by x of z, which is equal to h of z, is equal to 1 plus 2 by 5 z power minus 1 plus 3 by 4 z power minus 2 plus 1 by 3 z power minus 3. From the derivation of lattice structure, we know hm of z is equal to am of z, which is equal to 1 plus summation k ranges from 1 to m am of k into z power minus k. Okay. Now, I know looking into the expression, so the order of filter is 3 because we have the highest power as 3. So, m is 3, so let us substitute the value of m. Therefore, A3 of z is equal to 1 plus summation k1 to 3 A3 of k z power minus k. Now let us expand this equation to find out what is A3 of z. Therefore, A3 of z is equal to 1 plus A3 of 1 into z power minus 1 plus A3 of 2 into z power minus 2 plus A3 of 3 into z power minus 3. So this is the equation which we got. Okay. So now let me term this equation as equation 1 and let this equation be equation 2. Now if I compare equation 1 and 2, so this is nothing but our h of z. So if we compare equation 1 and 2, so can I find out the coefficient A3 of 1, A3 of 2 and A3 of 3? Because both are in the similar fashion? Yes. Therefore, comparing equation 1 and equation 2, so what is the coefficient of z power minus 1 here? It is A3 of 1, and in this equation the coefficient is 2 by 5. So A3 of 1 is equal to 2 by 5. Similarly, the coefficient of z power minus 2 here is A3 of 2, and here the coefficient of z power minus 2 is 3 by 4. And what is A3 of 3? A3 of 3 is equal to 1 by 3. And we all know Km is equal to Am of m. So, the conclusion part which we did in lattice structure, yes. What is the value of m which we took here? It is K3, which is equal to A3 of 3. So, which is nothing but the value of K3 is same as the value of A3 of 3. So, what is A3 of 3? That is equal to 1 by 3. So, we got the first coefficient of the lattice structure, that is K3. Now, I should find out what is K1 and K. We also know that Am minus 1 of I is nothing but equal to this equation, and where I ranges from 1 to up to m minus 1. Okay. Now the value of m is 3. So 3 minus 1 is 2. Therefore, the value of I which we will get is 1 and 2. So with the help of this data, I should find out what is K1 and K2. Let us start with step 1. So in step 1, let m be equal to 3. So if m is equal to 3, then the values for I is equal to 1 and 2, correct? Now let me substitute the first value of I. Let I be equal to 1. So if I is equal to 1 in this equation and if m is equal to 3, m is 3, 3 minus 1 is 2, of 1, the value of I is 1, this is I, okay, which is equal to A3 of 1 minus A3 of 3 into A3 of 3 minus 1 is 2 whole divided by 1 minus K3 square. Okay. Do I know all the datas? Yes. So what is A3 of 1? A3 of 1 is 2 by 5. Substitute it here. 2 by 5 minus A3 of 3 is 1 by 3 into A3 of 2 is 3 by 4 whole divided by 1 minus 1 by 3. K3 value is 1 by 3, the whole square. So after simplifying that particular equation, the value of A2 of 1 is equal to 0.169. Now let us give the second value of I, that is let I be equal to 2 in the standard equation. So if so, we get m minus 1 is 2, the value of m is 3 of 2 will be equal to A3 of 2 minus A3 of 3, A3 of 3 minus 2 is 1 whole divided by 1 minus K3 square. Okay. Again I need to substitute the data and I should find out what is A3 of 2. So A3 of 2 is 3 by 4 minus A3 of 3 is 1 by 3 into 2 by 5 whole divided by 1 minus 1 by 3 the whole square. So if I simplify this, the value of A2 of 2 is 0.693. This is A2 of 2. And we know the standard equation Km will be equal to Am of m. So what is the m value here which I am getting? 2 of 2. So this is nothing but equal to K2. So we found out the second coefficient, that is K2. Now I should find out the last coefficient. For that, let the value of m be equal to 2. So step 2. In step 2, let m be equal to 2. Okay. If m is equal to 2, I ranges from 1 to m minus 1. M is 2, 2 minus 1 is 1. So the value of I which we will get is only 1. Okay. Let us substitute these two equations in the standard equation. So if I substitute A, 2 minus 1 is 1, I is also equal to 1, which is equal to A, 2 of 1 minus A2 of 2, A2 of 2 minus 1 is 1 whole divided by 1 minus K2 square. Okay. Now if I substitute the values, A2 of 1 is, this is A2 of 2, A2 of 1 value I have written here, it is 0.169 minus, what is A2 of 2? It is 0.693 into A2 of 1 is again 0.169 whole divided by 1 minus K2 square. What is K2 equal to? It is equal to 0.693 the whole square. Okay. If I simplify this, we will get 0.0998. So which is equal to A1 of 1. So we know A1 of 1 is nothing but equal to K1. So did I find out all the three coefficients? Yes. Now I should draw the lattice structure with the help of these three coefficients. So what I have done, I have tabulated all the coefficients which was needed, which we calculated using the formulas, that is am minus 1 of I, which is equal to am of I minus am of m into am of m minus I divided by 1 minus km square. So and the other formula was km, which was equal to am of m. So with the help of those two formulas, in 2 steps we found out k1, k2 and k3. Now I should draw the structure. The structure remains same, that is, you take input x of n, you divide it into 2. So here you will have a delay unit. So you give this to an adder, and similarly here also you have an adder. So this input is fed to this adder and this input is fed to this adder, and here the coefficient is k1 in the structure. So what is the value of k1? It is nothing but equal to 0.0998. Similarly here it was k1, which is equal to 0.0998. Okay. Now again this output will be fed to the next adder. This output will be delayed once, and that also will be fed to an adder, and the input from this path is given to the top adder, and here the coefficient which we multiply is k2, and the value of k2 is 0.693. Again from here we feed to this adder where k2 is equal to 0.693. Okay, we completed the second stage. This output is fed to the next adder. This is delayed once, z bar minus 1. The next adder, we give this input to the top adder, from there we give it to the bottom adder. Here the coefficient is k3 and the value of k3 is 0.333. Here also we take k3, which is equal to 0.333, and here the output which we get is y of n. Okay. So this is nothing but the structure of lattice FIR filter, that is lattice structure for FIR filter. So the structure, the standard structure remains as it is. What we do is, from the given difference equation, we try to find out the coefficients k1, k2 and k3 based on the order of the filters. Since it was order 3, we get 3 coefficients, that is k1, k2, k3. Draw the structure, and in the place of k1 write the values, in the place of k2 write the values, in the place of k3 write the values. So this is how we can draw the lattice structure with the help of the difference equation. So what I did, from the difference equation I deduced the system function. Then we know that hm of z was equal to a polynomial am of z. Then from the equation of am of z we deduced a3 of 1, a3 of 2 and a3 of 3, where a3 of 3 is equal to k3. There we got the first coefficient. Then with the help of two formulas, km formula as well as am of I am minus 1 of I formula, we deduced the rest of the two coefficients, that is k1 and k2. Later we draw the structure, that is lattice structure. Now let us move on to second problem. Second question is, they have given us h of z and they are telling us to draw lattice structure. So in the previous problem what they did, they gave us y of n. With the help of z transform we obtain h of z, but here they have directly given h of z. So we know h of z is equal to am of z, which is equal to 1 plus summation k ranges from 1 to m am of k into z bar minus k. So the value of m is 4 because the highest power of z is 4. So if I substitute that, a4 of z, h of z, which is equal to a4 of z, will be equal to 1 plus summation k ranges from 1 to 4 am of k into z bar minus k. So if I expand this, h of z will be equal to 1 plus a4 of 1 into z bar minus 1 plus a4 of 2 into z bar minus 2 plus a4 of 3 into z bar minus 3 plus a4 of 4 into z bar minus 4. Now let us term this as equation. So let this be equation 1, let this be equation 2. Now if I compare equation 1 and 2, a4 of 1 is equal to 3 by 4. a4 of 2 is equal to 17 by 8. a4 of 3 is equal to 3 by 4. a4 of 4 which is equal to 1 which is equal to k4. Okay. Since it is a4 of 4, that is obviously equal to k4 and the value of k4 is equal to 1. We got first parameter. Now in order to find out the next coefficient, I should use the formula am minus 1 of I, which is equal to am of I minus am of m into am of m minus I whole divided by 1 minus km square. In step 1, let m be equal to 4. If m is equal to 4, I ranges from 1 to 3. So if I substitute the values here, a 4 minus 1 is 3 of 1. I am taking the first value of I. Let I be equal to 1. If I is equal to 1, a4 of 1 minus a4 of 4, a4 of m minus 1, that is 4 minus 1 is 3, whole divided by 1 minus 1 square. K4 is, so this is K4 square. If I substitute the equations here, a4 of 3 is 3 by 4 minus 1 into 3 by 4 divided by 1 minus 1. In the numerator also we get 0, in the denominator also we get 0. So therefore this is equal to undefined. Okay. If I substitute the value of I as 2, let I be equal to 2 in the equation. What happens to the equation? A 4 minus 1 is 3 of 2, which is equal to a4 of 2 minus a4 of 4 into a4 of 4 minus 2 is 2, whole divided by 1 minus k4 square. Correct. Now if I substitute the values, a3 of 2 will be equal to a4 of 2 is 17 by 8 minus 1 into a4 of 2 is 17 by 8 divided by 1 minus 1 square. Again this is equal to undefined. Okay. So in the numerator also it is 0, in the denominator also it is 0, which is equal to undefined. Similarly, if I substitute the value of I as 3, the value of a 1 of 3 is also equal to undefined. So when it is undefined, we will not get the coefficient, so therefore we could not draw the structure for this kind of problem. So whenever it is a problem which results in the state of undefined, kindly stop the problem to this stage. The next problem is, given the 3-stage lattice filter with coefficients k1 1 by 4, k2 1 by 4, k3 1 by 3, determine the FIR filter coefficient for direct form structure. So what they have done, they have given us the lattice structure coefficient. We should try to find out the direct form structure coefficients. For that, we know the output of first order lattice structure f1 of n is equal to f0 of n plus k1 into g0 of n minus 1, which is equal to x of n plus k1 into x of n minus 1. Similarly, g1 of n was equal to k1 into f0 of n plus g0 of n minus 1. So this was equal to k1 into x of n plus x of n minus 1. So this was the output of first stage. This was y of n. So they are telling us 3 stages. So it should have 3 stages. So if I look into the output of second stage, y2 of n will be equal to f1 of n plus k2 into g1 of n minus 1. What I am doing is just remember this formula. Instead of 0 in the first stage, for the second stage it tends to 1. Wherever we have 0 we tend to 1, wherever we have it tends to 2. Rest of the parameters remains as it is. Okay. So if I substitute f1 of n equation here, this will be equal to x of n plus k1 into x of n minus 1 plus k2 into, we know what is g1 of n. So I should know what is g1 of n minus 1. For that, what I should do, wherever we have n, I should replace it with n minus 1. So I will write it directly. So k1 into x of n minus 1 plus x of n minus 2. Okay. So if I simplify this, I can write it as x of n plus k1 plus k1 into k2 into x of n minus 1 plus k2 into x of n minus 2. Okay. So this is f2 of n. So if I write the expression for g2 of n, g2 of n will be equal to k1 into f1 of n plus g1 of n minus 1. Again, if I substitute the expression here, k1 into x of n plus, I should substitute the expression for f1, this will be k2, okay, k1 into x of n minus 1 plus g1 of n minus 1 will be equal to k1 into x of n minus 1 plus x of n minus 2. Now if I simplify this, so this will be equal to k2 into x of n plus k1 plus k1 k2 into x of n minus 1 plus x of n minus 2. So this is the expression for G2. So we are done with the output of the second stage. Now I should find out the output of third stage because they have given us the 3-stage lattice structure. So the output of third stage y3 of n, so this f3 of n which is equal to y of n will be equal to f2 of n. So I am writing the same equation. Wherever I have 1 I am replacing it with 2, wherever I have 2 I am replacing it with 3. So just that is a simple way in which you can write the equation instead of by hearting. Plus k3 into g2 of n minus 1. Okay. Now I know what is f2 of n. So we have simplified it here. Just write down that. Therefore y of n is equal to x of n plus k1 plus k1 k2 into x of n minus 1 plus k2 into x of n minus 2 plus k3 into, I should write the expression for g2 of n minus 1, but I know what is g2 of n. So if I rewrite this equation, so what will be the expression? I can write it as k2 into x of n minus 1 plus, so I will write it here, k1 plus k1 k2 into x of n minus 2 plus x of n minus 3. Okay. So we are ready with the equation for y of n. So let me simplify this. Therefore y of n will be equal to, we have only one x of n term, I will write it as it is, plus, so wherever I have x of n minus 1, here we have and here we have. So if I rewrite the equation, it will be k1 plus k1 k2 plus k2 k3 into x of n minus 1, correct. Similarly, next I should write x of n minus 2, here we have, here we have. So plus k2 plus k1 k3 plus k1 k2 k3 into x of n minus 2 plus, so we have only one x of n minus 3 term, that is multiplied with k3. k3 into x of n minus 3. Term this as equation star. We got the output for third stage. So we know the standard equation for y of n will be equal to x of n. We know that y of n is equal to x of n plus summation k ranges from 1 to m a m of k into x of n minus k. What is the value of m? 3. So if I substitute that, x of n plus summation k, which is equal to 1 to 3 a3 of k into x of n minus k. Okay, let us expand this. So if I expand x of n plus a3 of 1 into x of n minus 1 plus a3 of 2 into x of n minus 2 plus a3 of 3 into x of n minus 3. So this is the standard equation which we got. So let me term this as star dash. Okay. Now if I compare star and star dash, the left hand side of star is y of n, star dash is also y of n. Okay. So now let us start equating the coefficients of x of n minus 1, x of n minus 2 and x of n minus 3, which gives us the expression by which we can find out the coefficients for direct form structure. What I should do? Comparing star and star dash. So what is the coefficient of x of n minus 1 here? This one. And here it is x of n minus 1, it is a3 of 1. Therefore, a3 of 1 is equal to k1 plus k1 k2 plus k2 k3. Okay. So do I know the values of k1, k2, k3? Yes, it is given. So let us substitute 1 by 4 plus 1 by 4 into 1 by 4 plus 1 by 4 into 1 by 3. If I simplify this, a3 of 1 will be equal to 0.3958. We found out the first coefficient. Okay. Now I should find out the second. For that, what let us do is, let us compare the coefficient of x of n minus 2 in star with that of star dash. So what we got? Therefore, a3 of 2 is equal to k2 plus k1 k3 plus k1 k2 k3. So if I substitute the values, k2 is 1 by 4, k1 is 1 by 4, k3 is 1 by 3 plus 1 by 4 into 1 by 4 into 1 by 3. The value of a3 of 2 is 0.354. We got the second coefficient also. And the last one is, so compare the coefficient of x of n minus 3 is k3. Here it is a3 of 3. Therefore, a3 of 3, which is equal to k3, and the value of k3 is 1 by 3. So we got this coefficient also. So we wanted all the three coefficients. So we found out all the three coefficients of direct form structure with the help of the coefficients of lattice structure. The next problem is, let the coefficient of a three-stage FIR lattice filter be k1, k2, k3. They have given all the three values, and they are telling us to find out the coefficient of direct form structure, and they are telling us to draw the block diagram, which means that we should draw the direct form structure figure. So what I have done is, in the previous problem only we solved what is the relationship between the three-stage lattice structure coefficient with that of the direct form structure. So I have directly taken the formulas and I have found out what is a2 of 1, a3 of 1, a3 of 2. Now we know the standard expression for y of n is nothing but equal to x of n plus summation k ranges from 1 to m a m of k into x of n minus k. Since they are telling it as 3-stage, the value of m is 3. So if I substitute in this equation, y of n will be equal to x of n plus summation k ranges from 1 to 3 a3 of k into x of n minus k. So if we expand this, x of n plus a3 of 1 into x of n minus 1 plus a3 of 2 into x of n minus 2 plus A3 of 3 into x of n minus 3. Okay. Now, I know the values for A3 of 1 which we have calculated, A3 of 2 that is also calculated, and what is A3 of 3? We know that, so I will write it here, we know that A3 of 3 is nothing but equal to K3, yes or no? What is the value of K3? K3 is 0.3. Okay. Now, let us substitute A3 of 1, A3 of 2, A3 of 3 in this equation. So, if I substitute y of n will be equal to x of n plus A3 of 1 is 0.18 into x of n minus 1 plus A3 of 2 is 0.236 into x of n minus 2 plus 0.3 into x of n minus 3. So, did we find out the difference equation? Yes. With the help of difference equation, can I easily draw the direct form structure? Yes. So, x of n is the input. It is getting divided into two branches. X of n is multiplied with 1 and it is given to adder. Okay. X of n is delayed once, gives us x of n minus 1 which has to be multiplied and given to adder with 0.18. Again this has to be delayed once which gives us x of n minus 2. Feed the output of this adder to the next adder and this should be multiplied with 0.236 and it should be given to the adder. Okay. Now, again this should be delayed once, gives us x of n minus 3 which has to be multiplied with 0.3, and if I give it to the adder, the output here is. So, like this we can draw the direct form structure with the help of the coefficients of lattice structure. So, these are the different kinds of problems which we can deal in lattice structure. So, in today's class we saw what is a direct form structure and how to realize that, and then we saw how to realize lattice structure. We saw few problems on that. So, we have one more structure, that is cascade structure, which we will be covering in next class. Thank you.